In many manufactured goods, industrial processes, this quality of the surface is essential. Whether it's a linear motion, rotary motion, things that have to operate with bearings or across perhaps wiper seals, a super clean surface is an essential part of product quality. But how clean is clean, and how do you measure that cleanliness? I'm with Mark Zander. He's the sales specialist for industrial microscopes at Olympus, Canada. Mark, I understand we're standing next to an inspection device which lets us determine what contaminants are on, for example, a machined or manufactured surface.
Yeah, so our new CIX 100 microscope is a turnkey solution for looking at cleanliness on any manufactured parts. So we find a lot of aerospace manufacturers as well as automotive manufacturers will be interested in our CIX 100 because they normally do gravimetric analysis for cleanliness, and they'll take a part that comes off the line, they'll put a solvent over it, they'll then run it through a vacuum system. They'll weigh that after drying it in an oven. They take the membrane, then place it onto our stage, and all of the contaminants that show up on that filter membrane can actually be scanned for both reflective, non-reflective, and the particle size and count number.
Okay, so to be clear, this is non-destructive testing. So we're not actually cutting apart or sampling the part surface itself. No. We're washing potential contaminants off the part and then checking what we have washed off.
Exactly. So it's a non-destructive test. You're not actually destructively having to break down the part. You're washing a solution over it and then looking at all the particles that come off of that part. So if you have an air intake or you have a shock and there's a moving component in it, or you're a manufacturer that's afraid of taking those contaminants and putting it into a motor, you would want your part to be very, very clean and to not have any metal particulate on it, to have very little fibrous particulate. And a lot of automotive companies now are actually asking for you to meet certain specifications and standards, and this system will allow you to do that.
Now, could this be used as a part of an online quality control process, just as random sampling from a production run, for example?
Yeah, so if you have one product line that you're running continuously, you would take every 100 parts or every 100th part off of the line, and you would perform a cleanliness inspection on it, and you would take the membrane, do your analysis, create a report in our software, and then keep that in a database that you could then provide to the customer to show that it's past cleanliness.
Is it possible to use it almost forensically? If we have a failure in process, could we use it on the back end of it, if you will?
Yeah, so I mean, maybe your customer is interested in finding out what that part looked like in terms of all the particulate that was found on it, and they would be able to go in and look at the report, and you can save all that raw data to go back and look at it at a later time point.
And what sort of resolution are we looking at? How small a particle can you detect?
So you can detect from 2.5 microns all the way up to 45 millimeter particle sizes.
So we're looking at particle sizes that are far below what a human eye would typically pick up in most cases.
Yeah, you can see it roughly, but you can't actually detect what that particle is. So you can see here that this particle is very small, and it'll allow you to see if it's a metallic versus a non-metallic particle, or if it's a fiber, and all of that is done automated in the CIX 100 software. And as well, it also provides all of that into a document in a tabular form for them to look through and see each individual particulate that showed up on the membrane.
Automated microscopy for surface cleanliness from Olympus, says Mark Zander.